Good afternoon to one and all. So today we are going to see about the advantages of per unit system. So already we have seen what is a per unit system, how we are going to calculate. Now we are going to see the advantages of per unit system. So in that, per unit impedance referred to either side of the single phase transformer is the same. So, as I said in the previous class, the per unit impedance referred to either side of the single phase transformer is the same. And also the per unit referred to either side of the three phase transformer, regardless of the three phase condition, like primary and secondary side, the per unit is same. Next, the confusion between the line and phase quantities in the three phase balance system is reduced. Okay, the confusion between the line and phase quantities in the three phase balance system is being reduced. Next, the manufacturers usually provide impedance in the terms of per unit. Okay, so if you go with the confusions means, so you need to identify what are the line quantities, you need to identify what are the phase quantities in the three phase balance system. So, that is being reduced, okay, reduced in the per unit system. Next, manufacturers usually provide impedance values in the per unit that already be. So manufacturers, if you take all the if you are going to purchase a generator, okay, they will provide the that values in the per unit. Okay, next, so why they are mentioning that the per unit means for a simulating purpose. For simulating purpose, it is very easy. Otherwise, the simulating will take more time. Okay, simulating will take more time. Say for example, why I am saying is, say for example, your generator. You are purchasing a generator that is in megawatt. Okay, and if you take the transmission line that is in kilowatt, and if you take the transformer that is in MVA. Okay, and if you take the some load that is in megawatt, so you need to convert all this into a common scale. Common scale in the sense this megawatt is converted into kilowatt, and this transmission line is kilowatt. Okay, and this transformer rating in MVA you have to convert into kilovolt amperes. Next, so say for example, one single generator is there, one single transformer is there, one some sort of load is there. So there it is very easy. But in practical cases, there are n number of generators, n number of transmission lines, like transmission lines, next to n number of transformers and n number of loads might be there. So in that case, simulating becomes very complex. Okay, simulating becomes very complex. So if you are directly take that values in the per unit, it will be very easy for us to simulate also. And that's what I said. Computational effort in the power system is being reduced. What is computational effort? Computational effort means that, say, for example, if you want to simulate, okay, so if you provide all the things in per unit, it's very easy to compute, okay, and go with the answer. So that is the computational effort. Say, for example, it is in single phase system. So whatever the per phase values that is given in the problem, that you need to take it as base MVA or base kilo. So you have to remember whatever the per phase values given in the problem, that you need to take as base MVA and base kilo. How to calculate this base current, that is in kilo amperes? So base current kilo amperes is equal to base MVA divided by base kilo. So base MVA divided by base kilo. So how you have to remember this now? Just P is equal to VA. Okay, so P is equal to VA, I is equal to P by V. So current is equal to, that is base MVA divided by kilowatt. That's all. So this you need to remember. Base current is equal to base MVA divided by base kilowatt. This you need to remember. How to calculate the base impedance in the sense, base impedance. So V is equal to IR. This is also from the basic relation. V is equal to IR. Then, V is equal to I into Z. So Z is equal to V by I. So base impedance in ohms is equal to V by I. That is base kilovolt divided by base kilo amperes. So you need to convert this kilo amperes in terms of this. Already we have seen. Okay, so this equation you need to substitute here. That is base kilovolt divided by base kilo ampere is equal to base MVA divided by base kilo. So if you substitute here, base kilovolt divided by base MVA divided by base kilovolt. So this base kilovolt goes here. So base impedance in ohms is equal to base kilovolt square divided by base MVA. So this is the formula for calculating the base impedance. So base impedance equal to base kilovolt square divided by base MVA. So this you need to remember. If you don't remember also, no issues. You just derive with the formula already you know. That is Z equal to V by A. So I is equal to P by V. That you substitute, automatically you will get this solution. So, but if you remember, the time for solving this problem might be same. That is base impedance equal to base kilovolt square divided by base MVA. So this thing you need to remember. Next step. What is base MVA? Base MVA, how to calculate this base MVA instance? So whatever the given in the problem, that you need to take it as base megawatt. That is base megawatts equal to base MVA. Okay, next, how to calculate this base per unit impedance. Per unit impedance equal to actual impedance divided by base impedance. Actual impedance Z actual divided by Z base. Per unit impedance equal to actual impedance divided by base impedance. For three-phase system, you need to remember. So three-phase MVA is given. So that you need to take it as base MVA value. Three-phase MVA will be given. That you need to take that as base MVA value. Next, line to line kilovolt that is given in the problem, that you need to take as base kilovolt. Okay, line to line kilovolt that you need to take as base kilovolt. Next, how to calculate base voltage per phase. So base voltage per phase is equal to base kilovolt line to line divided by 3. Base voltage per phase. So per phase means you need to divided by 3. So base kilovolt line to line divided by 3. How to calculate the base current per phase? Base current per phase is equal to base MVA in 3 phase divided by 3. Okay, the whole divided by base kilovolt line to line divided by 3. Okay, base current per phase is equal to base MVA divided by 3 phase base MVA in 3 phase divided by 3 divided by base kilovolt line to line divided by 3. So as we seen in the single phase, how to calculate base current in the single phase now, base MVA okay, divided by base kilovolt. Okay, so base kilovolt divided by, so here in 3 phase it is base MVA divided by 3 and the whole divided by base kilovolt line to line divided by 3. So that is nothing but base MVA in 3 phase divided by √3 into, if you simplify this 3 and √3, base MVA in 3 phase divided by √3 into base kilovolt line to line. Okay, so this is the formula for calculating the base current per phase. Base current per phase is equal to base MVA in 3 phase, the whole divided by √3 into base kilovolt line to line. So this is the formula for calculating the base current per phase. That is base MVA in 3 phase divided by √3 into base kilovolt line to line. Next, how to calculate this base impedance? Base impedance equal to base kilovolt line to line, the whole square divided by base MVA in 3 phase. Because already we calculated this base impedance. Base impedance is equal to base kilovolt line to line divided by base MVA in 3 phase. But base kilovolt line to line, the whole square. Whole square, how you know? Okay, because Z is equal to, so based on this, okay, so Z is equal to V by I. So base impedance equal to base kilovolt square divided by base M. Similarly, here in 3 phase, base base impedance equal to base kilovolt line to line, the whole square divided by base MVA in 3 phase. So this you need to remember for the 3 phase. Next, 3 phase circuit, the same thing, just a revision. So base current is equal to SB. SB is nothing but MVA base. That is MVA base divided by E3 into P base. So, okay. So next, the base impedance. How to calculate the base impedance equal to VB divided by root 3 into I base. Okay. So VB divided by root 3 into I base. So that is the formula for calculating the base impedance. So next is in terms of current I said no. So current is the MVA base divided by root 3 into V base. So that you need to substitute here. Okay, that you need to substitute here. While simplification, base impedance equal to kilovolt, the base, the whole square divided by MVA base. So base impedance ZB is equal to kilovolt base, the whole square divided by MVA base. Already we have seen, just it is a revision. Okay. Next, what is nothing but change of base? Change of base. This also we have seen. Sometimes the per unit impedance of the machine, say for example, generator, transformer, or motor, etc., of the system is expressed in the base other than the selected one as a base for the system in the which the machine is located. The actual impedance of the machine depends only on the material and construction. This unchanged by changing in the rating of the machine. However, the base is changed. The per unit impedance of the machine takes on a new value. Say, for example, how to calculate this per unit impedance, the actual impedance divided by base impedance that we. So actual impedance divided by base impedance, we already calculated base impedance equal to base kilovolts square divided by base MVA. That you need to substitute here. So this denominator base MVA goes here. So actual per unit impedance equal to actual impedance divided by KVB squared into MVA base. So this is the formula for calculating the per unit impedance. So you need to remember what is this per unit impedance. That is actual impedance divided by KVB squared into MVA base. So next, this is very, very important for we are going to use, okay, this thing in our uh, problems. Okay, to change from base impedance or base given base to per unit impedance on a new base. So is that per unit given or old value? Okay, so some book it will be given as given value, some book it is given as old value. So Z per unit old is equal to Z actual divided by KVB squared old into MVA, MVB, MVAB old. So that is from the previous formula. Okay. So Z per unit, that is per unit impedance equal to actual impedance divided by KVB squared into MVA base. The same formula here also, but here you are calculating the old values. So that is nothing but Z per unit old is equal to Z actual divided by KVB squared old into MVB old. Okay. Next, what is actual value? That is actual value, how to calculate just this, this actual you are taking here and this to here. Now. So Z actual is equal to Z per unit volt into KVB squared volt divided by MVA volt. So this is the formula for calculating Z actual. So what is the formula for calculating Z per unit new? So similarly, Z per unit volt we have calculated the same formula. This is the basic formula. So Z per unit mu is equal to Z actual divided by KBB square mu into MVA base mu. Okay, so MVA base mu. This is the formula for calculating the mu Z per unit value. But here already we have Z actual value already we have calculated. So just you are substituting, we are substituting here. Okay, so that this formula we are substituting here. So we are calculating Z per unit mu is equal to Z per unit volt into KVB volt divided by KVB mu the whole square into MVA base mu divided by MVB volt. So this is the formula for calculating the Z per unit mu. That is Z per unit mu is equal to Z per unit volt into KVB volt divided by KVB mu the whole squared into MVA base mu divided by MVA base volt. Okay, so this is the actual formula for calculating the Z per unit mu. So this formula you need to remember. Okay, so if you don't remember, also you can come up with this formulation, but it will take more time. If you remember easily, you can substitute and calculate the Z per unit mu values. So Z per unit mu is equal to Z per unit volt into kVb volt divided by kVb mu the whole square into MVB mu divided by MVA volt. So this formula you need to take down, okay, for calculating the Z per unit mu in the problems. Okay. So next is also same. So so here one point. Okay. So here one point we need to note down. So per unit impedance of the transformer is same whether referred to on primary or secondary side of the transformer, which is not the case of when considering the absolute values of these impedance. Okay, so per unit value of the transformer is same whether referred on primary and secondary side of the transformer, but not in the case while considering absolute impedance. If the values of impedance are absolute value, like a secondary primary side is equal to per unit impedance of primary side and equal to secondary side will not be applicable in the when the absolute values of impedance is given. Otherwise, Z per unit primary is equal to Z per unit secondary for transformers, not only for single phase and also for the three phase also same. And it is one of the major advantages of this per unit system. Okay, this is the one of the major advantage of the per unit system that you need to remember. Next, so these are the some of the points. These are the some of the points you should you should remember while solving. Okay, the per unit representation. What are the some that important points in the sense? So first, base kilovolt and base MVA are selected on a part of the system. So base, when selecting the base kilovolt or base MVA, you need to select from one part of the system. So that you need to remember. Either you say, for example, left to right, but generally the Indian standards we are following the left to right basis. Okay, so from generator, transmission line, load, transformer line. So like that reverse don't go for, because we are generating and we are transmitting and we are based on that we are calculating the system. So basically you have to go with this part. So either you need to select this base kilowatt and base MVA are selected in the one part of the system. Okay, next base MVA will be same in all the parts of the system. Say for example, if you select one base MVA, it should be same in the all the parts of the system. This you need to remember. Okay, because base MVA, once it is selected, it needs to be continued in all the parts of the system. Next, for other parts of the system, the base KVA for each part is determined by using the line-to-line voltage ratio of the transformer. Okay, so if you selected one base, okay, if you want to select the other parts, the base KVA for each part is determined by using the line-to-line voltage ratios of the transformer. So this point also you need to remember. Next, for single phase transformer connected on a three-phase unit. Say, for example, a single phase transformer connected on a three-phase unit, the three-phase rating are to be determined from the single phase rating of the each individual transformer. Sometimes what we'll do while doing a simulation, what we'll do is instead of going for, say, for example, instead of going for three-phase like a three-phase transformer or three-phase generator, we'll use three generators, okay, three single-phase generators like that. So same like that. So three-phase rating are to be determined from the single-phase rating of each individual transformer. So these points also you need to remember. So next, some of the hints that also you need to remember for calculating this. Okay, so what are the hints? Capacity rating. Okay, so capacity rating is nothing but MVA rating of three-phase operation. So that is nothing but 3 into MVA rating of single-phase transformer. So capacity rating is nothing but MVA rating of three-phase operation, or otherwise in other terms, 3 into MVA rating of single-phase transformer. Okay, so for three-phase, this is for three-phase. So next is voltage rating. Voltage rating, how to get a voltage rating of primary and secondary of three-phase transformer depends on the connection. Okay, depends on the connection. Hence, voltage rating of three-phase transformer is to be calculated for primary and secondary windings separately. Okay, say for example, it depends on the connection, what connection it is. So that connection we'll see in the next slides. Okay, so what is that? Yeah. So what is that thing is that when the primary or secondary winding is connected in the star, then the voltage rating of the corresponding winding of the three-phase transformer is nothing but 3 into voltage rating of the single-phase transformer. Okay. So whenever the primary and secondary winding is connected at a star connected, then the voltage rating of the corresponding winding of three-phase transformers is nothing but 3 into voltage rating of the single phase transformer. So this thing you need to remember. These are the some of the points you need to remember. Next point is that when the primary or secondary winding is connected in delta, okay, delta, then the voltage rating of the corresponding winding of three-phase transformer is equal to rating of the single phase transformer. So these also you need to remember. So, okay, when the primary or secondary winding is connected in delta connected, then the voltage rating of corresponding winding of three-phase transformers is nothing but rating of the single-phase transformer. So this also you need to remember. So next, in delta connection, line voltage is equal to phase voltage. So V line is equal to V phase and I line is equal to root 3 into I phase. So that is for delta connection. This already we know that just we need to remember for solving our problems. Next, star connection. V line is equal to root 3 into V phase is equal to I phase. So this also you need to remember for calculating the certain things, like calculating the whether it is for delta connection and whether it is for star connection, that you need to remember. That is I line is equal to I phase for star connected transformer. Okay.